use of earth switch. If this question is asked in the examination, you have to write like this. When the line is disconnected from the substation, when the maintenance of the line has to be done, but it is not enough from the viewpoint of the safety, because EMF is induced in the line wires when another line passes near the line, or there is some voltage on the line because of forming the capacitance due to the line and earth or the line and ground. This may result in shock to the operator. To prevent this, it is necessary to ground the three line conductors after the line is disconnected. For this purpose, earth switch is used. Explain basics of interlocking of switchgear in power systems. So when the maintenance has to be carried out on circuit breaker, it is not just enough to open the circuit breaker, as the contacts are on one side are live, as these are connected to the bus bars. So it becomes necessary to isolate from the live side also. For this, isolators are used. Isolators are connected on either side, that is both the sides of the circuit breaker. The isolators are opened after the opening of the circuit breaker. So the circuit breaker is isolated from both the sides. Now the isolator is designed only to carry the rated current, and it is not designed to break the fault current. So if the isolator is opened before the opening of circuit breaker, arc is produced across its contacts and it may result in fire. Operator also gets hurt. So the isolator should never be opened before opening the circuit breaker. Similarly, when the circuit is closed, first the isolator should be closed and then only the circuit breaker should be closed. Otherwise, the circuit breaker is disconnected or isolated from both the sides. It is not connected with the bus bars. If the earth switch has to be operated, then it should be closed after the opening of the circuit breaker and the isolator. And while closing the circuit, first the earth switch should be opened and then the isolator should be closed and then the circuit breaker should be closed. Arrangement of interlocking is provided so that the isolator cannot be opened when the circuit breaker is closed and the circuit breaker cannot be closed when the isolator is in open condition. Similarly, the interlock is also provided so that the earth switch can be closed only when the circuit breaker is in open condition and the isolator can be closed only when the earth switch is in open condition. So this is the basics of interlocking of switch gears in power system to maintain the system healthy condition and for the maintenance purpose. Sequence of opening and closing the circuit breaker, isolator and earth switch. By opening, first of all, open circuit breaker as it is on load switch. Then open isolator. So this is off load switch, and then close earth switch if provided to ground the residual charge available on the poles. While closing, first of all open earth switch, close isolator, and then make the contacts of the circuit breaker. Give any 4 points of differences between fuse and circuit breaker. Fuse works on thermal and electrical properties of the conducting materials, whereas circuit breaker works on switching principle and electromagnetism. Fuse does not give any indication of overloads, whereas breaker can give an indication of overload. Fuse can be used only once. Once it blows out, you cannot use it again, whereas in case of circuit breaker, you can use it many number of times. Fuse provides protection against overload only, whereas circuit breaker can provide protection against overload as well as short circuit. Fuse can detect and interrupt faulty circuit conditions only, whereas circuit breaker can interrupt the process only, as well as it can be operated with the help of relays which are enabled to detect the fault in the system. Fuse can be used for lower breaking capacity as compared to the circuit breaker, whereas circuit breakers having a high breaking capacity. The operation of the fuse is automatic only. You cannot manually operate the fuse, whereas in case of circuit breaker, either manual or automatic operation can be done. The operating time of fuse is very low, whereas the operating time of breaker can be 0.02 second to 0.05 seconds. The operation time of both fuse as well as circuit breaker can be changed, and the operating value of the time of fuse can be dependent on the value of the current flowing through. the intensity or the magnitude of the current from flowing in case of fault through this fuse. The cost of the fuse is very low as well as whereas the cost of the circuit breaker is very high. Compare isolator and circuit breaker. So isolator is designed to operate on no load condition, whereas circuit breaker is used to switch off and switch on the load current in the healthy condition and to break the fault current also. So construction of the isolator is simple, whereas the construction of a circuit breaker is complicated. Isolator requires reduced or less maintenance, whereas in case of circuit breaker, maintenance is more as compared to isolator. Isolator is less costly, whereas circuit breaker is more costly. Isolator may be manually or motor or pneumatically operated, whereas circuit breaker is manually as well as automatically operated. Isolator, in case of isolator, there is no question of arcing as the current has not to be broken because it has not to break the current. It is operate on no load condition. Whereas in case of circuit breaker, arc is always produced as the current has to be broken or the contacts are separated when the circuit is on load condition. So the arrangement has to be done to quench the arc produced. For this, separate quenching medium is required. There are main contacts only in case of isolator, whereas in case of circuit breakers, there are main contacts as well as auxiliary contacts. So these are some points for the preparation of the comparison between isolator and circuit breaker. State the general information of circuit breaker. So in power supply system, it is a large network and there are different parts in it which operate at different voltage level as well as different current levels. These circuits are open and closed as per the requirement. Moreover, the faulty components should be isolated from the system when the fault occurs so that the healthy system works properly. All these are performed by the circuit breaker. Thus, the circuit breaker is a device which makes the circuit on and off manually or remotely in the healthy condition. It breaks the circuit automatically in the faulty condition. It can make the circuit on manually or remotely in the faulty condition. So this is the basic or general information of circuit breaker. State the basic working of circuit breaker. So there is one fixed contact and one moving contact in circuit breaker. Circuit is on when these contacts are closed like this and the current flows through both the contacts. The contacts inside the circuit breaker remain closed, allowing the current to flow through the circuit uninterrupted, means continuously from one end to the another end. Now when a fault occurs, such as like an overcurrent or short circuit, a sensing mechanism inside the breaker detects the fault. The sensor activates the trip circuit or trip unit, which releases a mechanical latch. This latch opens the breaker contacts and interrupting the current flow. When the contacts are open, an electrical arc forms between them. An arc is produced between these contacts. Large heat is produced due to this arc and it may result in damage. Moreover, there is a possibility of explosion also. The circuit does not break totally until the arc is extinguished. So, arrangements should be made to quench this arc quickly or rapidly as early as possible. The breaker has an arc quenching mechanism to extinguish this arc quickly. So this is how the basic working of a circuit breaker explained to you. List different components of a circuit breaker. So there are contacts, arc separator, operating mechanism, trip unit, terminal connectors, insulating material, enclosure or housing, arc quenching mechanism or medium, bimetallic strip in case of thermal trip units, electromagnet or solenoid in magnetic trip units, auxiliary contacts, interlocking mechanism. These are some main components or different parts of a circuit breaker. Give brief information about circuit breaker contacts. So, contacts are made up of copper and silver plating is done over it. They carry normal load current during normal healthy condition and specifically designed to make or break the circuit under fault conditions. there is one fixed contact and one moving contact in circuit breaker. Normally, the fixed contact is holotype and the solid contact is fixed inside the fixed contact like this. So, when the circuit has to be broken, the moving contact comes out of the fixed contact with the help of operating mechanism. Arc is produced across the contacts when the contacts are being separated. So, this is brief information about the circuit breaker contacts and their function. Different types of contacts of circuit breaker. So there are several types of circuit breaker contacts available. Mainly there are butt type contacts, knife blade type contacts, tulip type contacts, wedge type contacts, finger or multi-finger contacts, bridge type contacts, ring type contacts, and cone type contacts. So all these contacts we are going to learn in detail with their diagrams, so you can understand in a better manner. But if they are only to state different types of contacts, you just remember these names and write it down in the examination. Brief about construction details of tulip type contacts in circuit breaker. So in tulip type contacts, it's made up of copper or copper alloys, often with silver or gold plating at the tip of for enhanced conductivity and corrosion resistance. The fixed contact is of a cylinder type and solid moving contact in it. The spring-loaded metallic fingers arranged radially. You can see in the figure this. These are some fingers which are arranged radially. You can easily visualize the same. Commonly 6 or 12 depending on the current rating. The cross-sectional view is also included in this figure, so you can visualize this. This is the moving contact, this is a stationary or fixed contact, and these are the fingers made up of copper or copper alloys. Silver plating is done. The arc is struck between the fixed contact and the moving contact when the moving contact comes out of the fixed contact. So the arc is struck between these two contacts. These are some fixed contacts and this is the moving contact which moves away or out of this fixed contacts. Contact tube or this male plug, the counterpart of this tulip type contacts, a cylindrical solid conductor, usually copper or aluminum. This slides into the tulip fingers, means like this. This is the male contact and this is like connected. So helical coil spring or disc springs positions behind or around the fingers to provide uniform radial pressure to ensure the tight and stable contact around the incoming male contact. So this is like this. This is a spring contact which holds the tight this male contact or moving contact. Insulating housing typically made up of epoxy resin, ceramic or high-grade insulating polymers encases the contact assembly to provide electrical dielectric strength and mechanical support. The tulip contact may be of fixed or mounted or on a movable arm or insulating rod, depending on its role, that is either a busbar, breaker or isolator. Mounting arrangement is bolted or riveted to the contact base or support flange for secure positioning. So in the figure you can visualize this. This is the physical context of tulip type context of a circuit breaker. This is generally used for the vacuum circuit breaker, 3-phase like R, Y and V. These are the tulip fingers or the fixed contacts. So their assembly is with the diagram you can easily understand this. This is the fixed contacts. These are fixed nut and this is the copper rod. That is the connection of the contact. This is the contact box where the male contact is going to be connected like this. So these are fixed contacts or tulip fingers and inserted the moving contact inside it. The same assembly you can visualize in this figure as well. So this is how tulip contacts are constructed and they can be utilized in the breaker. State the advantages of tulip type contacts. So there are several advantages of tulip type contact. Some of are listed over here. So first is self-aligning capability. So it allows smooth connection even with slight misalignment, because if it fixes in the male or female contacts, fixes like this, so it can allow smooth connection. Low contact resistance. It ensures the efficient current conduction because the moving male contacts are fixed in the female contact. So it ensures the low contact resistance because the contact area is very high. High mechanical flexibility. So spring loaded fingers accommodate thermal expansion and mechanical vibrations. The compact design, it saves the space in switchgear and circuit breaker assemblies, so it is one of the advantage. Low maintenance because minimum wear and tear due to the even pressure of distribution because the spring pressure is around the radial surface of the contact. So easy assembly and replacement. So modular structure allows for quick installation and servicing. High reliability. So they maintain strong contact under varying electrical and mechanical conditions. Suitable for frequent operations. So it is ideal for applications with regular switching or plug-in or plug-out requirements as per the application or requirements or necessity or the operational condition. So these are several advantages of tulip type contacts of circuit breakers. The limitations of tulip type contacts. So there are several disadvantages of this type of contact. Some of are listed over here and we are going to discuss right now. Due to the limited current carrying capacity, it is not ideal for very high current applications compared to voltage or welded contacts. Repeated insertions and withdrawals can wear down the contact finger and reduce its spring tension. Due to dust, moisture or corrosion, it can increase contact resistance and lead to overheating or arcing. It requires precise manufacturing and alignment, especially for high voltage or vacuum applications. Due to spring force, contact pressure limitations may decrease over time, affecting the reliability of the electrical connection. Uneven thermal expansion between contact fingers and plug can affect and fit and contact stability under temperature fluctuations. So these are several disadvantages of tulip type contacts. See the constructional details of finger and wedge type contacts with a proper figure. Fixed contacts are made up of two main parts. One is a number of spring loaded copper fingers that is silver plated arranged around the inner periphery. It provides the multiple current paths and ensures good electrical contact. A pair or more of copper jaws with a wedge-shaped slots mounted on the spring to grip the moving contact tightly. It is designed to withstand mechanical forces under fault currents. Moving contacts are shaped as a cylindrical copper plug with a tapered wedge portion. Front cylindrical part enters the finger cluster, ensuring many parallel electrical contacts. Rear wedge portion slides between the spring jaws of the fixed contact, giving strong mechanical grip and ensuring stable connection. The leaf spring is attached behind each finger strip. When the moving cylindrical contact enters, it pushes against the finger. The spring flexes and provides restoring force which tightens the grip. So this is how the construction of finger and wedge type contacts are carried out. So here you can visualize in this. These are the leaf spring which creates the pressure on the contacts. These are fixed contacts too. And this is the moving contact, a wedge type. So it is a finger and wedge type contacts. Here you can visualize the multiple fingers here which are connected or the leaf spring is provided across. So this is how the finger and wedge type contacts of a circuit breaker can be constructed. The advantages of finger and wedge type contact. So there are several advantages of this type of contact. Some of are listed over here. So finger contacts provide multiple parallel current paths, so reducing the resistance and heating. Wedge jaws ensure firm pressure and mechanical strength, allowing safe conduction of very high currents, including short circuit currents. Even if one finger contact gets slightly damaged or oxidized, other fingers maintain conduction and avoids no single point failure. Wedge portion provides strong grip, preventing the loosening under high electrodynamic forces during the fault conditions. Finger contacts with leaf spring self-adjust to misalignment and ensure uniform pressure throughout, whereas wedge ensures tight locking irrespective of minor positioning errors. Multiple fingers and wedge jaws distribute current and heat that avoid hot spots. Combination minimizes erosion, distributes stress and increases durability of breaker contacts. widely used in EHV circuit breakers, GIS, and high-rated air circuit breakers due to the robustness. Current transfer initially happens through finger contacts, reducing arcing stress on wedge jaws, ensure longer life. So these are several advantages of finger and wedge type contacts. The disadvantages of finger and wedge type contacts. So there are several disadvantages of this type of contacts. Some of are like, since both the finger and wedge contacts are combined, the design and manufacturing process becomes more complicated compared to individual contact types. Due to the added materials, that is finger contacts, wedge portion, leaf spring, etc., and precision required in alignment, the cost is higher or greater. More components mean increased chances of wear and tear, especially on finger springs and wedge surfaces, which makes inspection, lubrication, and replacement more difficult. Uneven pressure distribution between fingers and wedge may lead to localized heating and pitting at some point, accelerating wear. Combined contact arrangement needs more space compared to simple finger or wedge contacts. Since leaf or finger springs provide contact pressure, repeated operations may lead to spring weakening or fatigue, reducing the effectiveness. So these are several disadvantages of finger and wedge type contacts of circuit breaker. Brief about construction detail of butt type contacts. So these contacts involve two flat surfaces that come into contact directly face to face, like two flat plates. The contact area is usually either circular or rectangular. So these are the butt contacts, stationary contacts. You can see this, and it is the moving contact. So visualize this. These contacts are rectangular in shape, and the surface is circular one from the tip of the corners. You can see this. This is the circular one. So contact materials are made up of high conductivity materials such as metal contacts or metal alloys, so that the contact area may be reduced and arcing may be reduced. So this type of materials are silver alloys, copper, or silver tungsten. That is a mix of the metal, so it forms an alloy. It may include an arc resistance alloy on the surface. So these may reduce the contact resistance and arcing. A spring mechanism or mechanical pressure is applied to keep the contact pressure together firmly during its operation, ensuring the low contact resistance and smooth passing of the current during the normal operating condition. One contact is fixed, the other is the movable. See this? This is the fixed contact and this is the movable one. Here it is. These are the fixed contact and movable one. So fixed contact is this, movable contacts are this. Mounted on a moving arm or a mechanism that opens or closes during the operation. So these are mounted on the moving arm. You can see this on moving arm. This. So that they can contact during the operation, that is normally closed and opens when any abnormality occurs. Both contacts are mounted on insulating support to isolate them from the rest of the circuit and prevents the short circuit. So you can visualize this insulating support. This insulating support, here it is an insulating support, so that they can be isolated from whole circuit. Often used with arc separators or quenching chambers to manage arc formation when the contacts are separated. So this is how the butt contacts are used for the circuit breaker, and these are the constructional details. The advantages of butt type contacts. So there are several advantages. Some of are listed over here. So it has simple construction design and easy to manufacture or assemble. It is cost effective due to fewer mechanical parts compared to more complex design like tulip or finger type contacts. Compact design generally suitable for low and medium voltage circuit breakers where space saving is important. It provides a decent initial contact surface area, resulting in low contact resistance when clean and properly aligned. Because of the direct face-to-face contact and quick closing action, the arc duration can be slightly reduced during the closing. So these are some advantages of butt type contacts of circuit breaker. The disadvantages of butt type contacts. So there are limitations of mud type contact. So some of our we are discussing right now. It is not ideal for high current applications as they may overheat due to limited contact surface area, and also we have discussed or mentioned that these contacts are used for low and medium voltage circuit breakers, so the current carrying capacity of the contacts are limited. The contact phases erode more quickly due to the arc formation and mechanical impact during operation as they have higher wear and tear. Accumulative oxidation or carbon can increase contact resistance as there is no wiping action or poor self-cleaning action. Proper alignment is crucial. Misalignment can lead to poor contact or arcing. More prone to pitting, deformation and erosion over time compared to finger or tulip type contacts, and due to this, lifespan of these contacts are reduced or limited. So these are several disadvantages of mud type contacts of circuit breaker. State the constructional details of brush type contacts with a proper figure. So there are several components in this and its description is also given. So first is the contact itself, that is brush contact, and these brush contacts have a flexible finger or a strip. It is made up of fine metal wires or laminated copper strips. These brushes make contact with a moving or rotating conductive surface, that is shaft, ring or plug. This brush contact you are visualizing in the machine itself, where DC machine, in case of DC machine you see that there are carbon brushes placed in it, and these carbon brushes are taking current out or to the terminal itself, providing the current. So holder or brush carrier, a non-conductive frame or housing that holds the brush element in place and provides structural support. Spring or compression mechanism. The spring applies constant pressure to ensure good electrical contact with the matting surface, that is the rotating part, accommodating wear and vibration. The contact surface, typically a rotating or sliding cylindrical conductor, that is rotor, that is armature itself, ring or rail type of contact, that the brush contacts. So the contact surface is a circular one inside, and the brush is connecting to the outer periphery of that rotating part. It must be smooth and conductive. Arc chamber. So for high voltage application, to safely manage the arc during braking operations, arc chamber is placed and it is optional. So in this, these are fixed contacts of brush and these are moving contact moving outside. This is the rotating contact in between. So this is how the brush type contacts are used in the circuit breaker. Advantages of brush type contacts of circuit breaker. So there are several advantages. Some of are listed here. Brush type contacts in a circuit breaker are used in some designs, especially in low voltage air circuit breaker and certain high current applications instead of traditional bud or finger type contacts. Since many fine strips or brushes are used, the total effective contact area is higher. Multiple parallel contact paths reduces contact resistance and improves current carrying capacity and distribute the current and reducing the heating and power losses. Brush bundles dissipate heat more effectively than a single solid contact surface. Flexible brushes ensure better surface contact even with minor misalignment or wear and tear, and maintain reliable contact under vibrations and mechanical shocks. Since contact area is distributed among many strips, wear per strip is reduced, which increases the mechanical life of the breaker contacts. Less contact bounce compared to the rigid contacts, improving the reliability during the closing operation. Arc energy is distributed over multiple contact points, so each individual strip suffers less erosion or corrosion. So these are some advantages of brush type contacts of circuit breaker. Disadvantages of brush type contacts of circuit breaker. So they are more complicated to design and manufacture compared to the simple bud or finger type contacts. It requires more material, copper strip, flexible assembly and manufacturing effort for precise arrangement of multiple conducting strips. Hence, the cost is increased. Brushes are prone to oxidation, contamination, or loosening over the time. Hence, periodic inspection and cleaning are necessary. Continuous mechanical stress and heat may cause brushes to lose elasticity or deformation, reducing effective contact. Flexible brushes are not as robust as solid contacts, so they can wear out faster in harsh duty. Bundle contacts often need more space inside the circuit breaker compared to the compact bud type contacts. Since current is divided among many strips, some brushes may break current earlier than the others, which can lead to uneven arcing and localized erosion. Because of the complexity and maintenance issues, brush type contacts are less preferred in modern high voltage circuit breakers where bud or tulip type contacts dominate. So these are several disadvantages of brush type contacts of circuit breakers. The constructional details of ring type contact with a proper figure. So a circular hollow ring made of copper or silver coated copper serves as a stationary fixed contact, often slotted or split to allow slight expansion and good gripping of the moving contact. You can see in the figure, this is the fixed contact, the hollow ring is made up of copper or silver coated copper, which serves as a fixed contact. Often it is slotted, so these are slotted 1, 2, 3, 4, 5 and 6. These are slotting is done. This is a moving contact in between, which allows the good gripping. A cylindrical rod that enters the ring during contact engagement serves as a moving contact. So this is a moving contact. This you can see this circular. This is the cylindrical contact. Enters in the ring due to the engagement. It serves as a moving contact. It is typically spring loaded. These are the springs. You can visualize this. These are the springs at the end. To ensure good pressure and reliable contact, springs are placed around or inside the ring to maintain firm contact pressure and self-centering during the insertion, that is the moving contact inserting in the fixed contact. Arc interruption chambers are often accompanied by arc separators or gas insulated chambers to manage arc during the disconnection, because when the contacts are separated, the arc strikes between the fixed contact and moving contact. Both these male and female ring contacts are usually silver or nickel plated to reduce the contact resistance and oxidation, and due to that the arc is controlled. So this is the constructional detail of ring type contacts. Advantages of ring type contact. So there are several advantages of this ring type contact. Some of are listed over here. So the circular, that is 360 contact, ensures uniform current distribution, means balanced current flow, reducing hot spot and improving its efficiency. Multiple contact points and a large surface area offer reliable electrical contact under high current. So it is suitable for very high current applications. Ring structures help guide self-centering and alignment of the moving contact automatically, so minimizing the misalignment issues. So the misalignment issues are solved with the help of ring type structure. Due to the symmetrical shape, arc dispersion is more controlled because it is symmetrical in shape on all the sides, which enhances interrupting performance. Springs embedded in the ring apply uniform pressure, ensuring a firm grip and reducing contact resistance. Commonly used in gas-insulated switchgear and metal-enclosed systems where high performance at high voltage and current is needed. Less wear and erosion due to stable contact pressure and uniform force distribution, ensuring longer service life. The enveloping structure reduces the mechanical bounce while closing, so it improves the operational stability. So there are this type of several advantages of ring type contacts of a circuit breaker, and due to this it is very much used for high current applications. Limitations of ring type contacts. So there are several disadvantages as well. So, more complex construction design compared to butt or finger type contacts, requiring precise manufacturing and assembly. Due to the complexity and materials involved, like multiple springs and contact fingers, ring type contacts are generally more expensive than butt and finger type contacts. Though self-centering to an extent, the mechanism still demands accurate axial movement to avoid wear or improper contact. The circular structure and spring arrangement take up more radial space than the simple contacts, so it requires larger space. Inspection and replacement and maintenance are more complicated due to the multiple contacts and their enclosed structure. The entry and exit points of the moving contact may experience localized wear if not properly aligned or lubricated. It is not ideal for the application involving frequent plugging or plug-out cycles unless designed specifically for such uses. So these are several disadvantages of ring type contact.
Brief about insulation in circuit breaker. So in a circuit breaker, insulation is provided to isolate live parts, that is the part carrying current, from grounded parts and from each other to ensure the safe operation. Since a breaker must withstand normal operating voltages as well as the over voltages due to the switching surges or lightning impulses, reliable insulation is very critical. Insulation should be provided depending upon the voltage at which the circuit breaker has to be used. In oil circuit breaker, oil is used as insulation in addition to the quenching medium. Porcelain is also used as insulation. In short, insulation in circuit breakers ensure dielectric separation, safety and reliable fault clearing by withstanding both normal and abnormal voltage stresses. So this is just a basic brief information of insulation available in circuit breaker.
Brief about operating mechanism in circuit breaker. So the operating mechanism of a circuit breaker is the system that provides the force and movement required to open and close the breaker contacts, either manually or automatically under fault condition as well as during the healthy condition to check the operation. Operating mechanism is necessary to operate the circuit breaker. There is opening mechanism to make the contacts open and closing mechanism for closing the contacts. Opening mechanism is either spring operated or pneumatically operated, while the closing mechanism may be manually operated, pneumatically operated or motor operated. It has high speed and reliability and the ability to perform multiple operations, that is closing, opening, closing continuously without any delay. It must possess good mechanical strength and durability throughout the operation. So this is the brief information related to operating mechanism of circuit breaker.
Classify circuit breakers on the basis of interrupting medium. So on the basis of interrupting mediums, circuit breakers are classified into these 5 categories. First is air circuit breaker, oil circuit breaker, air blast circuit breaker, sulfur hexafluoride circuit breaker, that is SF6 circuit breaker, and last is vacuum circuit breaker. So these are some types of circuit breakers which are used on the base in the power system and are classified on the basis of interrupting medium. Classification of circuit breaker on the basis of service condition and on the basis of type of contacts. So classification based on the service condition is just whether it is installed indoor or outdoor. So indoor circuit breakers are there and outdoor circuit breakers are also there. Classification on the basis of types of contacts means the contacts, fixed and moving contacts available in the circuit breaker are different types. So first is either tulip types, finger or wedge type, butt type contacts, brush type contacts, ring type contacts or cone type contacts. So these are some types of contacts used. Classify circuit breaker on the basis of tank arrangement and mountings. So on the basis of arrangement of the tank, the circuit breaker can be classified for 2 types, that is separate tank for each pole
and single tank for all bolts of the circuit breaker. Now on the basis of mounting, they can be classified as front panel mounting, rear panel mounting or away from the panel. So there are three different types of mounting arrangement for the circuit breaker. So this is how the circuit breaker can be classified on the basis of tank arrangement and mountings. Classification of circuit breaker on the basis of methods of control. So on the basis of methods of controlling the circuit breaker, there are two types of control. One is the direct control and second one is the remote control. In case of remote controls technique, we have two different types of technique. One is electrical remote control and one is the pneumatic remote control. In case of electric remote control technique, we have two different types of techniques. One is motor control method and second is the solenoid control method. So this is how on the basis of methods of control, circuit breaker can be classified in two different.
Explain arc phenomenon. Arc is the column of ionized gas. When the contacts of the breakers are separated, process of ionization takes place. When the fault occurs, the value of the current passing through the contacts increases to a high value, and there is an increase in resistance as the contact area decreases. As the value of current is large, high potential gradient is produced. So the electrons are emitted from the surface of electrodes by the high field emission. Also high temperature is produced due to high current density. So electrons are emitted due to the thermal emission. Primary electrons produced cause secondary electrons by the process of collision with the atoms of the surrounding air. Process ionization continues due to the increase in the field strength, increase in the free mean path, and due to this thermal ionization, so the arc continues. This is the arc phenomenon.
Explain basic details about arc quenching medium. So when a circuit breaker opens under the load or fault conditions, the separating contacts produce an electric arc, because whenever the contacts are separating from the moving contacts are separating from the fixed contacts, it produces the arc due to the ionization of the surrounding medium. So arc is produced in the circuit breaker when the current carrying contacts are separated. So this arc must be quickly quenched to restore the insulation and stop current flow. The substance used for this purpose is called the arc quenching medium. Oil, air blast, sulfur hexafluoride, vacuum, etc. is used as the quenching medium. It helps in quenching the arc quickly. Desirable properties of this arc quenching medium are high dielectric strength, high thermal conductivity, fast deionization after the arc extinction, and non-toxic and must be stable during the operation. So these are some desirable qualities or properties of arc quenching medium. Explain arc voltage and classify methods of arc extinction. So in the figure, you can visualize the relation between the arc voltage and arc current at the time of short circuit. You can see this. This is the short circuit current, that is the arc current, and this is the arc voltage. See this? Yes. So arc voltage can be found out or given by the equation, that is E substitute A, that is the arc voltage or EMF of the arc is equals to A plus B into L under root of I. So L divided by under root of I. So A and B both are constant. E is the arc voltage, L is the length of the arc, and I is the arc current magnitude. The path of this arc is the highly resistive one. So the arc current is naturally in phase with the arc voltage due to the resistive nature. There is increase in the arc length at every loop. So there is increase in the arc length or arc voltage as the contacts are separated from, that is the moving contacts are separated from the fixed one. So the extinction of the arc can be with the help of two different methods. One is the high resistance interruption or rheostatic interruption, and second one is the low resistance interruption or current zero interruption. So on the basis of the arc interruption or arc extinction method, we can classify them in two different ways. One is the high resistance one and second one is the low resistance arc interruption method. Explain high resistance or rheostatic arc interruption method in circuit breaker. So in this method, the arc is controlled such that there is an increase in the resistance, that is arc resistance, with the increase in time. The method itself suggests that it is high resistance arc interruption. So the value of current decreases with increase in the value of current to such a low value that the arc cannot persist and the arc is extinguished or the arc is interrupted. In the AC circuit breakers, the arc voltage and arc current are in phase because the nature of the arc is purely resistive. So the arc voltage and current both are in phase. So when the arc current becomes zero, the voltage across the contacts of the breaker is almost zero. This is called the restriking. So the possibility of restriking of the arc becomes very less, but the energy dissipating in the arc is very high. This method is used in low and medium power AC and DC circuit breakers. So to increase the value of the arc resistance, this can be done by four ways. One is by increasing the length of the arc. So the resistance of the arc is increased by increasing the length of the arc because R is directly proportional to L. So when the length of the arc increases, the resistance naturally increases with the length increment. Now by cooling the arc, so when the arc cools, the voltage required to continue the ionization is more because as and when we are cooling it, we are giving the deionization or we are processing the deionization. So the arc may be quenched fast. So the cooling of the arc increases the effective resistance. By splitting the arc, so good amount of voltage is absorbed on the two contacts of the circuit breaker, means the moving and fixed contacts of the circuit breaker. So if the main arc is split into the number of small arcs, that is we are cutting down the main arc into small number of chunks, the voltage is absorbed on each splitter and there is decrease in the voltage. Now the last method is by decreasing the cross-sectional area of the arc. If the cross-sectional area of the arc is decreased, the voltage required to continue the arc is increased. That means the resistance of the arc increases. So to decrease the cross-sectional area of the arc, arrangement is made to pass the arc through the narrow space or contacts to reduce the cross-sectional area of the arc. So this is how the high resistance or rheostatic arc interruption method works in the circuit breaker.
List out the ways of arc extinction using high resistance arc interruption method. So there are mainly four ways of arc extinction using high resistance arc interruption method. In this, first is by increasing the length of the arc. Second is the cooling. By cooling the arc means the reducing the temperature of this arc. Third is the splitting, by splitting of the arc, and last is by decreasing the cross-sectional area of the arc. So these are four ways to extinguish the arc using high resistance arc interruption method.